Hi, welcome to STL, 3D Printing Digital Fabrication Podcast. My name is Scott Rocca,
I'm Bessels.
And I'm Ryan.
and he hates that opener. Anyway,
I hate to listen to it like 7,000 times.
today we're going to talk about one of the things that's actually in the title of our podcast, 3D printing. And it's something that we get asked a metric ball fuck ton. Is how do you get started in 3D printing? And it's a question that it gets old after a while, but it's something that we've learned how to answer very well.
How do you print an elephant?
In small parts, or you scale it down.
Yeah.
The first thing we're going to talk about is, can
It's a
you
bad
print me a
joke.
gun? No. Go fuck yourself. That is my answer. The thing, I actually thought about this on the way over here because I was having an imaginary argument with Bill O'Reilly in my head.
And how do those end?
Actually, it was going well. And I was thinking about it on the way over, and when you pose the question, it's like, if you're going to print a gun for somebody, you should hand them a Darwin Award to go with it, or an honorary Darwin Award. Because it's like, if you really want to make a gun that bad, go down to the hardware store and make a zip gun like everybody else does for the same price of the plastic.
Let me tell you, that
Yeah.
7-day waiting period is actually a pretty hard one if you try to 3D print it.
Yeah. So getting that out of the way, yeah. So the big question that I ask a lot of people when they come up and say, "Oh, I'd love to get a machine," is, what do you want to use it for? And there's some people that's, well, I got a kid and he's really interested in this and that. It's like, well, that's great. Get a starter machine. Get something that's going to be lower end that you can learn with and work with for a while.
Is your kid interested in it? Is another good question.
Yeah, is your kid really interested in it, or is it a toy for you and you're using your kid as an excuse?
Yeah.
Like, does your local library have one that you can use? Does your college, one of the departments, have one that you can use? Is there a local hackerspace that has one that you can get in touch with the guys that own it and try and use theirs? Are you an artist? That's always another question too. And you have to kind of look at a lot of these different things and figure out who around you has them and who you can go and talk to and look at their machine. Because viewing all the videos and things like that is one thing, but when you actually have one in person, it's a very different experience. It's like reading a book on how to drive a car and never actually driving one. It's, you need to actually go and experience it in person, and you can watch all these videos of stuff getting built and they might have music going or this or that, but these things make sounds, they sing. It's a very sensory immersive experience, because it's the smell of the plastic, the way that these things sound when they're running, all that kind of stuff.
And the way they sound when they break.
Yeah. We'll get to that in a second here.
Yep.
So that, it's like, look at the sources that you have available to you and around you and go from there. The other thing before we get to what my next point should have been was, what is your budget? Always look at what your budget is, because there's machines on the consumer market that'll run you from $300 to $3,000 and beyond.
That's the low-grade hobby models.
Uh,
Not even low-grade, but just hobby models.
That's the 300 end, is like the low grade introductory learner kind of machines. They're the low grade stuff around like the $300 to $800 range, depending on what you're looking at, will get you started, and it will get you printing stuff. And you're going to have failures with them. But the point of that is that you're learning why that machine failed, how to fix it, so that in the future you can upgrade to another machine. You can start printing parts for a better machine and put that together, buy all the kit parts, so on and so forth. Just like a kit car, you can do it all yourself.
Except your kit car can't make a larger, better one.
It depends. If you put a CNC machine inside your kit car, then it can.
I stay
Lowrider?
connected.
Yeah, there you go.
Lowrider.
Okay, too much fun.
Anyway, so definitely look at your budget. If you're looking for more of like the consumer professional grade, which Make has coined the term prosumer.
Well, that's a camera term. That's an everything term. It's
Yeah.
fairly common nowadays.
So like the prosumer, the professional consumer kind of grade, that's going to be the higher end models. And once you actually get past the FDM and prosumer resin machines, then you start to get into resellers, and those are the guys who are reselling the Stratus 3 systems, the big name machines, and those are going to run you anywhere between $5,000 and $8,000, all the way up to $500,000, depending on what you want.
Talking about commercial work.
Yeah, and those machines will do multiple filaments, all kinds of different machines, and depending on how old it is, the different stuff it can do. So definitely look at what your budget is, and the next thing you have to look at is your skill level. You definitely want to look at what kind of either maker or hacker you are. If you're just getting into it and you can barely fix stuff in your house, the beginner stuff's probably what you want, even if you're looking to spend big bucks. And part of the reason for that is some of these machines will come as a kit. You can get them assembled, but other ones will come as a kit. I have an Ultimaker, the original, and I love it. I got it as a kit, put it together, wouldn't have it any other way.
Yeah.
Because it's one of those things for when you get those kit machines, when you put it together, you understand how it goes together, and you have a better idea of how to fix it when it fails or where it needs to be upgraded. If you hear a noise coming from one side of the machine, you can go to it and figure out where it's coming from, because you know, oh, when I put it together, this is here and that's there, and I got to take this apart and put it all back together again.
Yeah, and you're not afraid to do that because you
Yeah.
put it together yourself.
Exactly. But with some of the other machines, like you have to call a service person out, or you like the big reseller type machines.
So
You have
just
to-
as annoying as a real printer or another printer, 2D printer.
kind of, yeah.
It gets more expensive though.
Much more expensive.
Like a normal printer in your house, you can just buy another one for $50 and you're fine.
Yeah. Sometimes it's cheaper to buy a whole new printer than to buy that cartridge ink.
Yeah.
So, I mean, you have to look at your skill level. If you're somebody who's very comfortable with this kind of stuff, you've built all kinds of crazy things before, one of the higher end machines might be more for you, even though the kit machines, the lower expense models may be more appealing. You'll get better results and better resolution out of the higher end machines.
Yeah.
But again, it's going to be preference too. So one of the other big things too is software. And there's going to be software that you're going to use directly with the machines, and that's called slicing software. That kind of stuff is what you basically are going to go from your design program to the slicing software to the printer. And when you do that, there's a couple of different ones that are out there. Depending on what kind of machine you're using, it's going to recommend different types. But there's also control software, but that's another thing entirely. Kiss Slicer and Slicer are two of the ones that are out there. They're pretty popular. They run on a base program called SkyForge, which is like saying Windows runs on DOS. It's the base program for doing all the slicing for it. And if you imagine a loaf of bread, it's a whole loaf. That is what you designed in your 3D program. You take it to the slicer, and that is the bread slicer. It takes it and it cuts it all up. And you put it on end, and you stack it all up like that. That is how the slices work. It's geometrically based, and it's going to be one piece at a time, at a time, at a time, at a time, that forms a complete object. Now, the other program that I use, and I really like the latest couple editions, is Cura. It's different from the SkyForge-based slicing programs. It runs on C++. It's drastically different. It slices in almost no time. I like it, but it's one of those things that it's not going to work for every machine. But what'll happen is you'll generate what's called G-code. G-code's a very old file and machine type format, but it's machine code. It tells motor X to run this far, motor Y to run this far, motor Z to run this far. And it tells motor E, which is usually your extruder motor, to push out this much filament and do this, that, and the other thing. So that's what the G code is going to control. I was just talking about the software for your design software, and there are hundreds of design programs out there. Ryan's actually very good with OpenSCAD. He's got a number of videos out there, kind of with some tutorials.
On this exact channel, they
Yeah.
suck. Comment and I'll make them better.
Exactly.
That's the plan.
And that's the same thing with every little side tangent again. If you comment on our videos, if you like what you see, tell us what you like, and we'll do more of that. Tell us what you didn't like, and we'll change it. We are here to help inform people and not just bolster our egos. We want to.
We like doing this.
Yeah, we do.
It's fun. It's really, really fun.
Yep.
Despite having to listen to my voice over and over again.
Yeah, I'm getting better. With this new mic, it takes almost no time to do now.
So yeah, back on point. So you have your design programs and software. There's a ton of them out there. There's open source versions and closed source versions. I like using AutoCAD and SolidWorks. Those are my two. That's kind of like my bread and butter when I design stuff.
I grew up learning those.
Yeah. So like that's what I love to use. I've used Inventor, Maya, a bunch of other ones. As far as the free stuff though, if you're a student and you have a student email address, Autodesk will give you free copies
Awesome.
of Inventor, SolidWorks, Maya, all of their Revit, all of them.
Pretty much your entire software suite.
Yeah,
Just because they want you to know it so that they can sell it to new companies because the people know it.
Exactly.
It must be good.
it's one of those things where we want it to be out there so people are using it and learning how to use it so that when they have a company or they go work for a company, they're not going to be lost because they did it 5 years ago in college, but they haven't touched it since because they can't afford it.
Yeah.
And they want people to license their software.
Yeah. But they can also track it too because then it's not cracked.
Exactly.
So the other stuff that's out there are the open source programs, and there's a ton of them. I know I like using SketchUp, which they hate, but that's a geometry-based program. It's really easy to use. I think it helps people start thinking in 3D. He disagrees.
When you get to the actual real, like SolidWorks and Pro E and all those tools, it's going to set you back drastically.
Yeah.
Working in OpenSCAD is completely different than working in those programs.
Yeah.
Well, there's parametric programs within within SolidWorks and Pro E that you can use, but I
Yeah.
mean,
Well-
it's a different mindset for that.
Well,
OpenSCAD actually allows you to think in mathematic terms to doing geometric shape stuff.
Yeah.
Yeah.
And SolidWorks doesn't just have parametric stuff. It is parametric.
Yeah.
And when we say parametric modeling, that means that you build upon an object step by step, and then you go back and edit each step. With some programs, you're not able to do that, and so once you create something, it's created, and you have to undo. And any changes you make at that undo point, everything from there is fresh. You can't step back forward. But there's other programs like 123D, Tinkercad, I know BobCAD.
HeexCAD? I think HeexCAD.
Yeah.
There's FreeCAD, which is okay. It's
Yeah.
the closest one that I've played with that's close to like a SolidWorks or Pro E.
Yeah.
But it's
It's missing some key features.
Yeah. And there's
It frustrates me.
there's a number of programs out there, and there's tons of tutorials on the web on how to do everything. It's a matter of what you want to make. If you're an artist who's interested in doing very organic things, a free program for you might be Blender. Blender's got a learning curve of a Mack truck hit. But that being said,
That sounds gentle actually compared to Blender.
yeah. That being said, though, Blender is a massively powerful program.
well, it used to be a closed source program until the company who developed it went out of business, and the people who were in the community just bought it and open sourced it.
Yeah.
And it's been improving ever since. It's an old program that's just been improved and worked on.
Yeah. They've kept it up to date, and they've kept improving in its technologies.
Once you know it, it's like walking.
Yeah.
It's very receptive to Python scripting.
Yeah.
The Peachy printer, the $100 printer that was just on Kickstarter a little while ago, actually runs on Blender script. So that's one of the ways that you can actually do stuff within Blender to create even more objects. So I mean, Blender's a great thing. The other one that's closed source but still really fun to use is Rhino. Rhino is a great program for artists and folks like that to use. I know we were at one of the local colleges talking to folks, and they put in a grant to get 3ds Max, which is that's a hugely robust and awesome program, and you can do a ton of stuff with that too. So I mean, your choices are extensive, and if you're on the consumer side and you're still a beginner and all that kind of stuff, before you go out and get a 3D printer, learn a little bit of software stuff. Because when you get that machine, all you're going to be able to do is download objects and print them. You want to be able to make some of your own stuff, make things that you enjoy. And
Certainly edit the stuff down.
yeah, one of the guys at the Hackerspace I made an object for. It was a new toilet flush handle.
And that's
the
not
old-
the
Well, it was
most
for the
fun
water.
thing.
Yeah.
The water valve on the below the toilet.
No, it wasn't for the water.
Oh, it wasn't for the water?
No, it was the actual flush thing.
Oh.
Yeah.
And that's not the most mundane thing he's asking.
Oh, why I'm saying I thought it was for the water valve because it has two hinges or like two knobby things on the side.
It's dual flush.
Yeah.
So you have one for solid, one for liquid.
Oh,
so
okay.
That way you use less water.
Yeah.
So that's why he actually had little divots in it so you could tell which one was which.
Yeah. But I taught him how to use well, Todd is a very, very bad term for that. I showed him OpenSCAD and he took off and learned it on his own.
OpenSCAD's it's CAD for programmers. So for a couple of guys here who are programmers, it's a lot easier for them to pick up. But it's something that anybody could really use.
It's not that hard. It's literally you say, hey, this is a cube. I need this cube in this position, and I need a circle cut out of this cube. And it's just building up from things like that. It looks a lot more complicated than it is, but once you get into it, it's fairly easy.
Yeah. So one of the other things that a lot of people ask us is like, well, how do you make, like, how do the shapeways people make stuff? It's the same process, right?
No. They're doing SLS stuff.
Yeah. And SLS is selective laser sintering. A lot of the machines on the consumer market are what are called FDM, which is filament deposition machine.
Modeling.
It's
you can look it up.
yeah.
Yeah. Filament deposition.
Filament deposition modeling.
Yeah, I had it right.
So
Fuse deposition modeling. Sorry.
there's
We're
a couple
all wrong.
Yay! So fuse deposition modeling. Yay for being wrong.
Yeah.
By the way, be prepared to fail. Be prepared to be wrong if you're just getting into things.
Play Dwarf Fortress. It'll teach you.
Yeah.
Losing is fun.
Dwarf Fortress is so good.
Anyway, so fuse deposition modeling, which is the process that you see a ton of stuff on right now. So that's the Ultimaker, MakerBot, Prusa, PrinterBot. All those guys use fuse deposition modeling.
It's basically how DIY people started.
Yeah.
Yeah.
It's a plotter and a hot glue gun had a bastard child, and that has birthed 3D printing. Birthed. That too.
Yeah.
So the other process is selective laser sintering. That's the one that the SLS method is the one that Shapeways and similar companies like that use. That is a very expensive process. You're talking tens of thousands of dollars to get started in that process. However, it will give you extremely high quality stuff and it give you a very wide range of materials to use. If you want to know how the SLS method actually works, I'd say actually Google it because you'll actually understand it a little bit better. The quick and dirty is that it's a powdered material. Your layer height is determined by the powder granule size, and you put that inside of a heated vacuum chamber, and that heat is close to what the melting temperature actually is. The laser comes over, heats, finishes heating the material to a state in which it will flow, and then each of those layers is fused together, and another layer of powdered material is brought across, and the process happens again. It still uses a slicing software, and it still creates things layer by layer. The nice thing with that method, though, is that you can create moving parts directly out of the powder material.
Well, because the resolution is you're basically printing with like a sand-like material.
Exactly.
Well, like sand-like feel.
Or you can actually print with sand.
No, yeah, you can do sand, but that's a lot more temperature, a lot more difficult.
Yeah. Well, I mean, that guy didn't.
If you had pure silica sand, then yes, you could do it easily. But
Well, one guy actually printed with sand using an SLS method, and
He had a parabolic mirror.
yeah, he had mirrors and
you're not getting pretty things out of it. You're not getting glass.
no.
Glass is hard.
Anyway, so the other method that is actually come to the consumer market is resin printing. And there's a couple different ways in which you can do resin printing, but the quick way to say it is that you can get really high resolution stuff. The stuff where their low res is sometimes where the high res version of the FDM machines start.
Oh, and they start at the price range of those FDM machines that are
Exactly.
getting those incredible prints.
So the two big names that are on the market right now are the B9C Creator and the Form 1. Those two run between $3,000 and $3,300. I can't remember the price of both those offhand, but it's between there. They're within a couple $100s of each other. They use different methods though to create their objects. The Form 1 uses a laser, UV laser, to cure resin, whereas the B9C will use a DLP projector. And so you can get really, really nice stuff. And the reviews that I've read for both say that the resolution on them is amazing. I know the B9C will get down to 50 microns. which is pretty much where I've maxed out on my machine for the moment. I need to do some more tuning on it to get any smaller, and I also have to change out the nozzle size. What was the other one? The Form 1 will actually get down to 25 microns. So it'll get even smaller than what the B9C can get. The biggest difference between the two, if you're an artist right now, especially if you do jewelry stuff, the B9C is your better option only because it has a burnable resin, which allows you to do rings and jewelry and all that kind of stuff very easily, and you can burn it out and do metal castings very
As
easily.
Charles' main complaint, though, is it won't go down to the .025. It only do the .05. But really, right now, it adds so much more ability that you can do.
You can always add extra material to go into finishing.
Yeah.
Yeah, I mean, the resin's easier to clean than the PLA.
Yeah, and one of the things too is you're talking about a $3,000 machine that will pump out stuff over a 24-hour period that would normally take a worker who is getting paid quite a good bit of money, a jeweler who is getting paid a lot of money to make a casting tree, that you can just say, okay, here's what I want to print, go.
Yeah.
Or even something closer in family.
There's actually
doing the job of a $100,000 metal printer over the course of a day.
Yeah.
Yeah.
Anybody who's going to ask about metal printers, they're out there and they're in the works. We talked about Vader. They're in the works right now, but it's still a little ways off. One guy printed with tin solder, and it worked up to a point, but even then, it was shoddy and looked like hell. Yeah. Yeah. That's an interesting video.
Yeah.
Anyway.
Okay. Apparently, I think I'm into that.
Whatever floats your boat. So the other, or probably the last thing that I'll say on it is you have to think about how much time you have, because you're going to be investing your time in learning how to model or edit files, learning how to use your machine, learning how to calibrate it, and how to go forward with it. And so you have to think about that. And yeah, sure, it'll be fun at first, it'll be work at first, but you have to be able and willing to keep up with that. Keep up on updating the machine, keep it maintained, all that kind of stuff.
It's a job.
To a point, it's a hobby. Is more like it.
Definitely
It can become a job.
Yeah, it can become a job.
Very serious hobby, though.
We're trying to make it a job.
Yeah.
Because we hate our jobs.
Well, I don't hate my job. I just would rather do this.
I don't hate my job either, but I don't like how much they pay me.
Oh, yeah.
Anyway.
I like to get paid more.
Yeah.
But that's
everybody wants to get paid more. Anyway, so there's a lot of stuff that you have to look at and you have to consider before going out purchasing. One of the things that I actually tell a lot of people when they come up to me is like, well, which one's the best? Which one should I get? I was like, stop, take a breath, go out, find the Make Magazine Ultimate Guide to 3D Printing. And I tell people that because it's going to give them a Consumer Report style breakdown on this is everything we tested. We did all the same models with every machine. Here's what happened. This was the pros. These were the cons. So, and the reason I tell people that too is because it gives you a good idea of what's on the market and what's available. Because the retailers that they're going to tell you about are reliable sources. And there's hundreds of companies selling 3D printers out there.
Yeah.
And you got to make sure that you're going to be going with a reputable dealer who's not going to just, toss a couple bricks in a shipping box and send it to you.
Or trying to knock off a bad RepRap clone.
Yeah, or they're cloning a machine and it's terrible. And even some of the Chinese-based machines are pretty... Some of them are really good. Some of them are just total and utter pieces of crap.
Yeah.
As one of our guys who attends our meetup found out.
Oh, yeah.
Yeah, he bought an Ultimaker clone, and he got it, and he's like, well, it prints really well, but the first couple layers look like crap. I was like, you're doing it wrong then.
Yeah.
So... it's stuff like that you have to look at too. It's like, yeah, sure, the Chinese machines that you can get on eBay, yeah, they'll work to a point. But
Or
at the
after
same
a point.
time, if you want something quality, you're gonna have to either pay for it or go through a reputable source. And PrinterBot on your low end is a good one to look at. The Prusa i3, those are actually fairly cheap, and it's a pretty good machine. And then all the way up to the Ultimaker and MakerBot stuff on the higher end.
We know quite a few people with, a couple people with printer bots who are pretty happy with them.
Yeah.
PrinterBot's actually a pretty good machine, and like I said, it's a learner machine, so it'll get you started, and you can learn a lot from them. Once they're calibrated and you've tuned them enough, and you learn how to use them.
They print beautifully.
Yeah, they do. They print really well.
We've got a guy who goes to Hackerspace named George.
Yeah.
Just the stuff that he puts out with it is just amazing.
Yeah. I actually first purchased the machine and ended up selling it to George just because I wasn't quite happy with it, and the stuff that he's getting out of it, I didn't think you could. And it's an amazing little machine. I've been surprised by it.
And that's where the time comes in. That's where you do the calibration, the working, the tweaking, the oiling, and everything, and learning your tools.
Yep.
And you can get great stuff out. Skimble, the guy who went to MakerBot like a couple years ago, he was doing beautiful, beautiful prints on a normal cupcake. He just spent tons and tons of times on it, and it's like, this is better than what they're creating with the Thingomatic.
Yep.
Again, it's time and patience.
Yeah. And then also, at some point, too, you have to be willing, it's like, well, do I want to invest the money and upgrade my machine a little bit, get a better hot end, get a different nozzle, get better motors, things like that you can also consider as expenses down the road.
Yeah.
So I know I've been looking at doing a Prusa i3 to kind of add to the collection of bots that I want to eventually have. And I can do one for about $250, $300. But that's because I have a ton of parts laying around. I know how to machine, so I can go and make my own nozzle and save money there. I've got extra heater blocks and cartridges, all this kind of stuff I have laying around already.
Which was basically already an investment of time.
Yeah.
Yeah.
And money, but
And experience.
exactly. But the more you work with them, the better you become. It's just like any other either hobby or career. The more you do with it, the more you go out and learn about it, the better you can get. So I think that's really my rant on getting started with 3D printing. I mean, do you guys have anything else?
No.
Not really. I mean, electronics could be a thing, but mostly you'll find out.
That's
by
another
doing it.
walk down paths, and it's solved for you.
Yeah.
You don't have to know it.
Yeah. I mean, if you're really into circuit boards and you want to get started with doing 3D printer boards, go for it. There's a ton of open source boards out there. A lot of them ride on top of an Arduino. Some of them don't. The Sanguino,
Sanguino.
yeah, Sanguino.
MakerBot's first.
That's a technical term.
Was that MakerBot?
That was a MakerBot thing.
Oh, really?
The current one is a derivative of the Sanguino Lulu board.
Interesting.
Yeah.
Didn't know that one. But yeah, I mean, there's a ton of boards out there. If you're really interested in doing that, go for it. But be willing to get something and mess around with it a little bit first, see how everything works. But yeah, that's pretty much my spiel and rant that I've developed over 9 months now of doing meetups and talking to folks about this stuff.
Getting the answer to the question every time.
Yeah.
Yep. And now you've done it one more time.
Yeah.
You'll have an even more well-formatted speech.
Yes, I will.
And we'll be doing it again this Friday, but you won't see this.
Yeah.
It'll be late. This will be up next week.
Yeah. So from the STL podcast, my name is Sky Rocka.
Yep. Basilisk.
And I'm Ryan.
Thanks for joining us. Have a good night.